Hi, this is Scott. I really appreciate our sponsors because they make the show possible. Today's show is sponsored by Developer Express. Become a UI superhero with Dev Express, controls, and libraries. Deliver elegant .NET solutions that address customer needs today by leveraging your existing knowledge. You can build next-generation touch-enabled solutions for tomorrow. You can download your free 30-day trial at dx.hanselminutes.com. That's dx.hanselminutes.com.
From hanselminutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 488. In this episode, Scott talks with Omoju Miller about redesigning computer science education.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes, and today I'm talking with Omoju Miller. She is the lead researcher on the Hippopathy project at UC Berkeley. She's got a degree in computer science, a master's in electrical engineering, and is currently deep into working on a doctorate on computer science education. Are you a PhD yet?
No, I am not. In a couple of weeks, we'll be Dr. Miller.
That is very exciting. Now, are you going to insist everyone call you doctor?
Absolutely not.
I think that if you spend that much time in school, though, it's your right.
No. Maybe to write some books and make money. Beyond that, I just wanted to have the knowledge for my own desires.
And what is your thesis on? What is the knowledge you've collected?
So what I've been working on is the social curricular activities that impact women and underrepresented minorities at a Research One university like Berkeley. Mm-hmm. We wanted to figure out if we could do things to help boost the representation of certain groups at the collegiate level. So we were running experiments if we design a new course from scratch, focusing on computational thinking. Would that attract more women? Would that attract more ethnic minorities? So it's a lot of work in introductory computer science. And when I first of all started this whole line of inquiry, I did not know that this would become something very, very interesting. I thought, it's intro computer science. I just want to know what's going on in this kind of space. I've now come to realize that creating the entryway for people is of paramount importance, because without a good entryway, they will never be able to ramp up in our field.
So is the postulate that existing intro to computer science courses are framed in such a way that they aren't attractive to all kinds of people?
Absolutely the case, yes. They're not attractive to most kinds of people. This is not necessarily just about women or ethnic minorities. This is about men too. The way we've done computer science right now, it only works for a small subset of the population. Even if you look at just men, white and Asian males, we still tend to skew towards a certain kind of personality. We don't have a diversity of personalities even within those groups. And it's because of the way that we teach things. We teach things in a very abstract, disembodied way. And we don't teach things to solve problems that real people have. We just teach you like almost discrete math, completely devoid of fleshing the whole thing out and actually solving a tangible problem for an organization.
That's interesting. There's always that personality type or that stereotype of the nerd that's focused on the tiny technical details. Mm-hmm. We always joke about Dungeons and Dragons. Right?
Yep.
But that is the personality type that is typically a very good programmer, because they're so detail oriented. They remember all the tiny little business rules and how they interact, and that allows them to see how a system works.
It is in fact the case that, yes, that kind of personality does well programming computer science, but it's a fallacy. That's not the only personality that does well with programming. Everybody has a level of slight obsession, if you want to call it that way.
Yeah, it depends on what they're obsessed about, but you're absolutely right.
Exactly. It depends on if you're interested. So for some people, they're interested in solving a particular problem for a specific reason. And given the problem, they will figure out everything they need to know. Some other people are actually not that interested in solving a particular problem. They are more interested in intellectual brain teasers. They're interested in something because it is hard and they want to make it simple. It doesn't have to matter if it's solving anything for anybody. So those kinds of personalities is what we have right now. People who are like obsessive puzzle solvers.
Yes, I think that's absolutely true. That's who I have been working with for the last 20 years.
And that person has a specific role to play. But as technology is becoming more and more ubiquitous and the end products of technology are beginning to interact more and more with people who are not technologically savvy, it is imperative that you have the other kinds of people in the field, because what ends up happening is you build a product and it has very low adoption because you've solved a problem that nobody even recognizes as a problem, and you haven't solved a problem that people are interested in. So it becomes, you write all these apps and they just clog the app store and they go nowhere.
So that comes at it from the kind of the top-down perspective, where apps are not designed for all different kinds of people, so they're not going to achieve ubiquity and achieve success. But from the bottom up, thinking about from like the metal up, is there something that we do in either education or programming language design or UI design to make computers more attractive to everyone, specifically the making of stuff and the writing of stuff as opposed to the consumption?
Yeah, absolutely. It's the case. The first number one challenge is the way you teach a programming language. So for example, if the very first taste you have is fighting syntax, for a lot of people, fighting syntax does not give them a sense of achievement. They want to solve a problem. Maybe they want to build their own version of Pac-Man. And they want, instant gratification. They were willing to spend an hour or 2 hours fiddling about with this thing, and then they see something that works. If that 2 hours is literally spent building a dev environment, which is the case oftentimes, depending on what kind of programming language you're starting off with,
right.
You're just like, I spent 2 hours building this dev environment and I have nothing to show for it.
Right.
If you start them off on something very, very simple, but teaches the fundamentals of computational thinking, something like Scratch, which is now Turing complete. Even though a lot of people give it like, oh, it's for kids, but it's one of those things that lets you appreciate computation just for computation's sake and still gives you that visual feedback very, very quickly. So you do something 30 minutes, there's something up there, and you can actually like send that little app to your friend and that friend can play something on that app. You feel a sense of accomplishment. All of a sudden you're like, oh my God, somebody's using something that I wrote, even though it might not be earth shattering. Once you can click that, oh my God, it's easier to move that person to Python or to Java and becoming much more complex problem solvers.
Yeah, yesterday at OzCon, at the open source conference, I took my 7-year-old and my 9-year-old, and we went to a Unity demonstration and class that was done by Stacy Mulcahy, and she showed the boys how to make a Flappy Bird game. And the part, and I'm not familiar with Unity. I knew that it exists and what it does, but what blew me away was that they put their sprite on the screen, and then they gave it a rigid body, two-dimensional physics attribute, and they hit play, and it dropped like a stone. And in my mind, the distance that was going to be required from, putting a sprite on the screen and getting it to behave like it had gravity was going to be quite a bit farther than that. We built a almost full game in about 2 hours.
Yeah. I mean, it's possible. And I think we that learned the old school way feel like, oh, no. It's going to take, that's 3 weeks worth of work to get to that point.
Exactly.
No. My 9-year-old, I went to his class. He goes to a school that is very project focused, and they will have coding. These kids have coding in their class. And they've been working on a project for 3 months, and there's a kind of demo day. You go in there and they show you what they built. And I am just in awe. This is at the point they're 8 years old. Flappy Birds and Angry Birds must be the thing. They built their own version of Flappy Birds. And the simulation was so realistic. And I was like, how did you guys get that? And they looked at me like I was broken. And they said, a physics engine, duh. I was just like, wow. So physics engine, who knew? They were just like, yeah, you get your physics engine into it so that your simulations are realistic. These are kids who now have a deep sense of what it is to create something. These are 9-year-old, 8-year-olds talking about a physics engine for realistic simulation. So they're focusing their energy on the computation. They're not fighting syntax. And they're actually building something that you will play and you will spend hours playing.
Right. And it seems like we, the leaders or the designers, the old people, are still maybe in the old world, not thinking about these new things. Because right now we have ubiquitous network.
Yep.
We have a very nice, clean layer of abstraction with HTTP. We can get resources very easily. We don't worry about zip file formats anymore. The thing, like I remember during when I was coming up, we still hadn't decided how to squish data, how to compress data.
Yep.
So
Data
many
compression.
problems have been solved, and we're
Eliminated.
exactly, yeah, even that's a great way to put it. Not just solved, eliminated. They are non-issues.
Yep.
Thereby, but computer science 101 is the same class it's been for the last 40 years.
Exactly. You want to teach people about data structures, which is fabulous. Everybody needs to know data structures. But the way we teach, it's almost like we're teaching, we forget that we're human beings. The best teacher is a salesperson. I have this fundamental idea that you cannot teach anybody anything. What you can do is guided facilitation. They have to decide they want to learn it. Once you turn on the light, they will go and get the knowledge that they need for themselves, and you will be the human that can help them figure out the bottlenecks faster. Because the world is so different now. Everything you literally need to know is available to you somewhere online. So the idea that I, the teacher, am the expert is no longer the case. I have a certain skill that I can support you in your learning, but I am no means the expert. You might end up being the expert for that area. I just need to unravel the little layers that's holding you back and get you on your way.
Wow. That just really blew my mind, because I was an adjunct professor for a while, and I would try to focus on knowing as much as I could about the topic so that I could, go and, bring the knowledge. But you're absolutely right. I mean, most of those kids were smarter than me already.
Yep.
I need to be a facilitator as much as a teacher.
And it's not even a good business case. Imagine being a CEO and you want to solve all the problems by yourself. There's no point. You're going to get a COO, CFO, CTO, and you have employees, and they solve problems in aggregation as a team. You are just the coach.
That's really, that's really a great way to put it. So then a well-structured computer science 101 class would be as much exploratory as it is absorbing, a knowledge about the past.
Absolutely. A well-structured class says day one, this is where we're going to get to in X amount of hours. This is the end goal. How we get to the end goal, we have a plan, but we might deviate from the plan. But know that this is the end goal. And we're going to co-create our path there together.
But how much history should there be, though? One of the things that I have appreciated with the being able to look back and say I was there and this was happening when I was coming up, and things like AOL and dial-up. You get a little bit of a get off my lawn kind of an attitude, but at the same time you get the perspective of history.
Yes.
And I want young people to appreciate that. I don't necessarily want them to suffer, like they don't need to use assembly.
No.
But they should know that the metal exists and that the machine code exists at some point. Like there should be a history of computers. Maybe it just shouldn't be in CS 101.
No, it should be there. I read this statement somewhere that it is injecting education into culture and not the other way around. And I'm an avid fan of history. You need to know the foundations. You need to understand what it is that you're standing on. Otherwise, what you build is not going to be successful. Because right now, you can bring somebody into an environment, teach them some frameworks and some JavaScript, and in 12 weeks, that person will say, I'm a junior developer. And have they built something? Yes, they have. Are they really a software engineer? That's pretty much stretching the word as far as it can go. Because you scratch the surface just a little bit and ask this person a simple question around list comprehension in Python. and the whole thing falls apart. Or you ask them a question of, why should I use a linked list, a doubly linked list versus a singly linked list? And then you're done. That's it. It's just like a glare. There's no depth there. So that's dangerous.
This episode of Hansel Minutes is brought to you by Audible. This is especially meaningful to me as I have been an Audible fan since the very beginning. I've listened to probably 100 audiobooks on a commute between Portland and Seattle. My favorite feature is Whisper Sync for voice. And that means that I can start reading on my Kindle, then listen to the Audible book and pick up exactly where I left off. My place is always synced between the two books. They've set up a special deal for you at audible.com/HanselMinutes. And I think that you should take that deal and you should get a book like Ready Player One or The Martian. There's some amazing books by David Sedaris or Neil Stephenson. All of our favorite authors are available at audible.com. And if you already own the Kindle book, you get discounts even then. It's just a fantastic service. And now that it is a part of the Amazon family, it's even better. Again, that's audible.com/HanselMinutes. You're already listening to this podcast. Why don't you try listening to audiobooks? Wouldn't they argue that you're being a little exclusionary and that those things aren't needed anymore? That being a Drupal developer is still a developer, as an example.
It is a developer, but it's not the same kinds of things. This is the best way I can explain it is this. I like to eat. I'm a foodie. Mm-hmm. And I live in this glorious place called Berkeley where we can get like Michelin level cuisine. Mm-hmm. So if the goal is to satiate my hunger, I can go to Chez Panisse, which is one of the top 50 restaurants in the world, and have this fabulous culinary experience. It will still satiate my hunger. On the other hand, I could just go to my local taco truck and eat something and my hunger is satiated. Those are two separate experiences. They solve the same problem, but they solve it in very, very interesting ways. If you are a Drupal developer and that is all you know, you're going to get very far, but you're not going to get as far as you could possibly go. You start off on your way and you're right there. But if what you want is to actually architect something from scratch or invent something amazing or have a very high level of sophistication about your craft, you're going to need to know about the bones of it. Software engineering is a high level vocational craft. It is a craft, but the craft rests on the layer of computer science, but it is a craft. So you need both of them. You need some parts of the computer science, and then you need to transition from a beginner to a master developer.
You know, this I love that you said craft. This concept of like craftsmanship and the idea of the apprentice.
Yes.
It's been lost. There's so many people, like you said, they go to a code camp and they come out a junior developer, or it's like, how do we balance the quality and the craft and trying to create high quality thinkers who can go and be software engineers in the real world? And at the same time, we want to make it, easy and make the onboarding experience for young people easy. Like, you don't want to say, all right, get started. It's easy. Look, you can make Flappy Bird in an hour. Now work for 15 years and maybe you'll get senior engineer.
Yes.
There's a balance.
There's a balance. So maybe not 15 years, but maybe a year. But like, there are no shortcuts to greatness. There's just not. And the hours you need to practice, you truly need to practice. We say over here that for you to get to a certain level of proficiency in anything, especially something technical, you need 15 hours a week for 50 weeks.
Is that 10,000 hours? Is that the Gladwell number?
It's not necessarily 10,000 hours. There are like 400 and something hours for you to really, really get good at something this technical.
True.
You need that time. Now, how you get to that time is up to you. It could take you 15 years to get to that level of time working on a certain data structure. Mm-hmm. Or it could take you 6 months if that's all you did. But how you get to the time is up to you. Getting to that time is completely inescapable. You got to get to practice and be that good at it. You cannot, 3 months is not enough time of practice.
Right. But isn't that's the funny dichotomy of all of this, is that you want to get them excited in an hour.
Yes.
But you don't want them to think at the end of that hour that they're done and they know computers.
Exactly. You don't want somebody to go to a hackathon and say, now hire me as a junior developer.
Right.
You want to let them know this is an onboarding on a journey. And what we will achieve in an hour is basically we've opened the door, but the journey has not started. You are Dorothy on the yellow brick road.
Mm-hmm.
We're not at Oz yet.
So how are you structuring these classes? I've taught Computer Science 101. I know how it was done in the late 90s.
Mm-hmm.
How should it be done tomorrow?
Tomorrow, the way that I would do it if I was doing Computer Science 101 tomorrow is basically tell you this is what we're trying to get at the end of whatever it is, 3 months, 4 months. And then treat my students as adults. I will literally still start them off in a drag and drop graphical environment like Scratch or Unity or anything like that. Mm-hmm. So that they can understand you can easily build something and get those juices flowing. Then I will then dial it back down and say, now that we've seen how we can build Flappy Birds, now we're going to go and learn the fundamentals. Mm-hmm. And then situate it in terms of society. And that last bit of situating it in terms of society is what I often don't see happening at all. You're just solving problems in a disembodied, disengaged way.
So that's really interesting, because I've done the let's make a game, and now let's look at how a circle gets drawn.
Yeah.
But how a circle gets drawn is super interesting to me. But I've tried to teach my wife, who has more degrees than I and speaks more languages than I, but has a focused disinterest in computer science. And how interesting it is to draw a circle and the math behind it.
She doesn't care.
Is even more of a turnoff. Like, if she could get even more disinterested in computers, it would be, let's do a class on how to draw a circle. But is it that kind of thinking that is getting us certain kinds of people in software?
It is absolutely that. So instead of we're going to draw a circle. After we draw the circle, let us actually talk about gaming. Do we like what we're seeing in gaming right now? Mm-hmm. What is a video game that you've played that you really absolutely love? How did that video game make you feel? And you talk about the psychology of building games and gamification and how you can continue on a quest in a video game forever and ever, and you never give up. Mm-hmm. And you bring that in and say, this is how education is supposed to be. And creating an environment where it's easy for you to fail. When you're trying to play a video game and you're trying to get to the next level, mm-hmm. nobody believes that they're going to reach the summit of the levels of the video game in their first try. That's why it's addictive. You just want to keep on trying so that you can get as far as you can. Mm-hmm. And you talk about all the mechanics of that. People are going to be engaged. And then you're going to go all the way back and say, now for us to build all this, we need to understand how to draw circles and polygons and rectangles and all this kind of other stuff. Then they're like, oh, okay, I see why we're doing this now.
That really works. That makes a lot of sense. I mean, this is where we want to go, and this circle drawing bit stands in our way. Let's just get that out of the way. We'll do that. But they need to see what the goal is, because if you go and try to teach someone that the circle is the goal.
No.
You're going to get a very specific kind of personality.
Exactly. And most people are going to be like, I don't care about the math behind this, no matter how interesting that math is. They're like, I don't care. How is this solving my problem? It's not solving a problem. I don't care. I don't want to do this again.
This is so funny, because I wrote an application in 1993 or 94 for the Palm Pilot.
Uh-huh.
The Palm, little black and white Palm.
The Palm Pilot, yeah.
So the Palm Pilot did not have a math library. Ah. Okay. It had no sine. It had no cosine. It also didn't have floating point.
Oh.
Yeah. So I took an integer and cut it in half and said, all right, these top bits are on the left of the decimal and these bottom bits are on the right of the decimal. And I basically wrote a, whole math library on a non-floating point to draw a circle. And I ran and I showed my then girlfriend, look at what I just did. I drew a circle on this,
Palm Pilot that didn't have this.
I just the disinterest was palpable.
Because she was like, and
Yeah.
I should be excited because
Exactly.
just doesn't get it. Doesn't get all the work you did. Like I literally invented scientific floating point method that didn't exist. I built this whole layer of abstraction.
Yeah. So by the time I'd done the flood fill, I think we'd broken up.
It's those things like why should I care? What literally it's always why should I care? It might seem so egotistical and narcissistic, but if you're teaching people, that's the first thing they want to know. Why should I care?
Well,
why should I listen to you?
So here's the thing. The application I wrote was a diabetes blood sugar management system.
Oh.
20 plus years ahead of its time. That particular person, disinterested in circle drawing, could have been potentially a really great business manager or project manager or UI designer, if I had only come at it from that direction.
Exactly. And that is the task that we as the computer science educator community has to solve. And not just for students who are 10 years old or 12 years old, for post-collegiate students.
Really?
Oh, yes.
We don't just give up on the old people.
No. Oh, absolutely not. That's my sweet spot. That's what I love working with. Because, when you're working with a 10-year-old kid, it's satisfying. The kid is doing this, is learning that. And maybe in 5 years or 16 years or 6 years, it will come to fruition. An adult, this is major now. An adult, right, knows nothing. And then a year from now, that person is a bona fide premium software engineer. And they're adding value to society in 12 months. That is amazing. And not only is it amazing from the fact that they're actually adding value, they're getting a livable wage that is kind of pretty awesome. So you can move people from poverty into the middle class in less than 12 months. And it's all legal. You're not doing anything illegal.
And it's all legal.
Yeah.
You should get a t-shirt that says, ask me about software engineering. And it's all legal. And that's a really great hashtag.
It's like selling crack, but it's the crack that we're selling is addiction to problem solving.
Yeah. It's
and
open source and it's free.
It.
It's open source free and you get paid for it. How could anyone not want this job?
Exactly. How could anyone not want this job? And then it's you can change your life. You could work from home. Every kind of personality is needed. If you never want to talk to a human being, there's a place for you. If you like talking to human beings all the time, guess what? You'll be a great product manager. There's something for everybody. If you're an artist, UI UX. If all you want to do is just tell stories all day long, there's a place for you in writing narratives for video games or movies. Any kind of personality at this point has a space in computer science.
It seems like we've got to convince people who are maybe set in their way that lots of different kinds of, what I call diversity in thinking is absolutely required on good teams.
Oh, absolutely. Especially if you're trying to solve some very hard problems. Like right now here at Berkeley, we're actually creating a development engineering minor that is interdisciplinary, because we've actually seen through research, if you create solutions to problems that people are interested in and the people guide the problems they get to pick, you actually build a more diverse team and you actually also attract diversity in that group. And you solve better problems and problems that the solutions have high adoption rates. Because oftentimes there's nothing more frustrating than having the solution to a problem and nobody cares. And it's not adopted and it doesn't actually make it to market. It's just sitting on a shelf or it's sitting in some archive or it's sitting in GitHub. Nothing is coming from it. That's the last mile problem. Actually adding value to society.
The thing that I try to use when I'm talking to people of any age about computers is the idea that this represents power.
Oh,
it is, if you feel disempowered, get even a little bit of technical understanding about what's going on and you start making your way up the ranks very, very quickly.
Absolutely. Absolutely. Very, very quickly. And for people who feel disempowered, especially, women are the most marginalized majority. They could have power. People of color who have been disproportionately weeded out, they could have power. And that's where data science actually is interesting, and statistics and data mining, because those are the parts of computation now that are very much driven by what the human is interested in finding out. So the kinds of experiments that get run on data are the kinds of experiments that the human decides they want to run. And because of the kinds of questions you ask, you'll find a different set of answers. And I think that's where diversity really, really comes to play and becomes even critical, even way more critical in getting great insight into large data sets.
Mm-hmm. Yeah, I think that people take the word diversity, which is simply a word, that it means literally what it means, and they start applying a lot more to it than maybe is necessary. And they also start thinking, well, this is about gender, this is about color, this is about...
No.
It is and it isn't.
Yeah, it's more than that.
Right. But it's that homogenous groups don't succeed.
No.
They die off.
Absolutely. It's just what it is. And this one, you don't even have to be a Christian to appreciate this. The stories of the gospel in the Bible, everybody's saying the same thing about an event they witnessed over a couple of years, but they're telling it from very different perspectives. And that is a diverse take on what happened. So maybe Mark tells it from his perspective, Luke tells it from his perspective, the other one tells it from his perspective. And somewhere along the line, if they're all telling the same story, at some point there should be some unity, and that's what happened. But you don't lose anything from having the diverse perspectives.
Very true. Very true. Well, thank you so much for chatting with me today.
Thank you so much, Scott, for inviting me. This was fun.
Well, hopefully by the time people listen to this, you will not just be soon to be Dr. Miller, but you will be actually Dr. Miller. So I wish you all the best.
Thank you so much.
This has been another episode of Hansel Minutes, and we'll see you again next week.